Here it is. Here there's a point P. Later we'll bring a problem. First we'll analyze, work out one by one. We'll cut this string, we'll cut this spring. Well, whatever we want, let's cut later. Slowly we'll develop the ideas. Now the system is in equilibrium. Okay, let's keep the question for our reference. Then first we'll show the system which is in equilibrium. At equilibrium, first we'll start with this one, m1g, spring force kx, here kx, m2g, here some tension t, here tension t, here some tension t naught, no problem, let it be there. So why you are putting different tension? Definitely this tension should balance the weight plus this tension, no? So definitely these two should be different tensions. This will be really very now what I'm going to do, I'm going to cut this part. This string is what I'm going to cut. When you cut it, how it will be?
Worked out.
Yeah, we have this one. Now you see. Start analyzing. The weight will act. What are the conditions? Let it be there in the problem. The weight of the blocks will act due to gravity. Fine. This is there. Then
Sir, there at M2, above M2, why the string will become loose, sir?
if you cut this rope, this everything will become loose. No, there's a one common string. Why this will become loose means this everything is one common string. No.
Yes, sir.
Okay. No. Let's get into this one. What will happen to this is loose. There's no tension here. Finish or leave it. Now let's come for this one. Block M2. Just after cutting string, there's no displacement of M2 and M1. So no change in spring force. So let's be as it is. Now net force on the block M2 you see downward. On the block M1, we'll put it in this way. Now we'll check first the block M2. Earlier there was net force 0. Now the net force is non-zero. From it was at rest, now it starts moving. So let's write the equation now. M2A2 equal to M2G plus Kx. Kx equal to, okay, from here I'll bring it. Kx equal to earlier tension something, let it be. And this T naught, okay, can we write T naught? So what is T? T minus. All these equations will write. Now tension equal to M2 plus M1 into G. The other T plus M3G, or say T minus M3G minus T naught equals 0. So T we know. Okay, the initial, these are all the tensions. Now, what is kx? Kx equal to m1g. What is the direction? Upward or downward? Should be downward. So the block M2 will start moving down. What about M1? Let's see it. M1A1 equal to M1G minus Kx. And Kx equal to in fact M1G. So block 1 will be attached, block 2 will be in motion. So block M1 shall I put like this? It will retain its inertia of rest. This is the main purpose. Why we are studying is just to conclude that laws of motion very systematically. Net force was 0. It was why it is at rest? Because net force is 0, inertia of pressure. Why again after cutting string, why it will not move? Net force 0. So it will continue to be its state of rest. It will continue its state of inertia of rest. Why this will start moving? Net force non-zero, it will start moving. Block M1 will be attached. What about M2? Block M2 what about M3? Shall we show any tension that blue color string? I want from students this one.
G and
Shall I write T naught?
zeros.
No, it's because the tension is set up by what? Pull forces. Pull forces, not push forces. The here what happens when you cut this, as weight M3G will act here. The M3G here what happens will try to push this. Pull forces will set up the tension, not the push forces. M3G is acting. Definitely this ground is there. So therefore here some sort of push forces is set up. This string now, after cutting, what we have to show? We have to show it
0.
like this.
Tension 0.
So that it will be loose. It is not cut, but it will be loose. Because the push forces cannot set up the tension in the string. So therefore MA3
G.
will be downward. So these are the accelerations of the block. Okay, we are going to discuss problems of these kind. I think we have to be a little bit alert. We don't have any big equations here.
Sir, in the third line, M2 should be transferred, no, sir?
M2?
M2 should be transferred from left side to right side, no, sir? You wrote M2 plus M1 by M1, sir.
Where you are asking?
So, right side, third line, sir. Yes.
Oh, this is M2, no? Yeah. So M2 I should send it to denominator, so this will become
M1 upon M2, sir.
1 plus M1 upon M2. Okay, yeah. Yeah, thank you. These are just some conclusions. So block M3 will move down.
Sir, block M2 will exert force on the spring and also the force will not
Block M2 will exert force.
on the spring.
Its weight is acting, spring force is acting. What is the thing exerting again?
It is coming with M2
Nothing. Don't think like this all. Block M3 will move down.
Okay.
New things don't introduce, at least. Hope everyone is getting slowly the idea. You have to just make observation. String is loose. lose tension 0. If a string is cut, the tension that will vanish. Then inertia of motion, inertia of rest. So will it continue to be in state of rest or state of motion? Net force non-zero, from rest it will get into motion. If net force is 0, it will continue to be in state of rest. These are
Sir,
the
we can
ideas
cut
is what we are
spring
talking.
also, sir.
Yeah, we can cut spring also. What is there?
Sir, here T naught will be greater than T or T will be greater than T naught.
Check it, ma, here. T should be greater than T naught, no? Mathematics, check it.
Okay.